Hello everyone and welcome back to our PySpark series. In today's video, we are focusing on a powerful SQL function in PySpark, the sum function for calculating cumulative sums within a window. Cumulative sums are essential for tracking values over time, analyzing trends and gaining insights within group data. We'll walk through how to set up and use the sum function within a window specification to calculate these running totals efficiently. So if you are ready to explore cumulative calculations in PySpark, let's dive in. Introduction to the sum function. The sum function in PySpark is a window function used to compute the cumulative sum of values across a specified range within a dataset. By calculating a running total based on a particular order, sum helps reveal trends and patterns over time or in sequential data. This cumulative sum is especially useful when working with financial data, time series analysis, or any scenario where tracking the accumulation of values is valuable. For example, in financial analysis, the cumulative sum can help visualize how revenue or expenses build up over months or quarters, allowing for insights into growth trends, spending patterns, or seasonal variations. Similarly, in time series data, a running total highlights changes over intervals, making it easier to identify upward or downward trends, cycles, or fluctuations. The sum function achieves this by applying a specified window specification, typically involving an order, such as by date or another sequential column, that dictates how values are summed within each partition of data. Using sum with a window in PySpark enables users to gain insights into cumulative data progressions directly within the data frame, allowing for efficient and detailed data analysis in a distributed environment. Basic syntax. In PySpark, the sum function with window specifications calculates a cumulative sum within a defined window of data. Using partition B, the data is divided into groups like regions, keeping each partition's cumulative total independent. Order by then specifies the sequence within each partition, such as by date. The cumulative range is set with rows between window dot unbounded preceding window dot current row, covering all rows from the start of the partition to the current row, thus creating a running total. For instance, data frame dot with column cumulative underscore sum value underscore column dot over window underscore spec adds a cumulative underscore sum column showing the cumulative sum in each partition ordered as specified. This approach is ideal for tracking trends, financials, and time series progressions. In time series progressions, why use sum for cumulative totals? The sum function for cumulative totals is crucial in analyzing how values build up over time or within groups. It's widely used in time series analysis to track accumulations like sales or expenses across periods, revealing patterns and trends. In financial reporting, cumulative sums provide essential metrics like year to date or month to date figures, offering a clear view of progress toward goals. Additionally, for data aggregation, cumulative totals help compare performance across groups, such as sales by department or region, making some a powerful tool for data driven insights and trend analysis. Practical examples. 1. Calculating cumulative sum of sales. In this example, we create a data frame containing product names and their respective sales and use PySpark sum function with the window specification to calculate the cumulative sum of sales in an ordered sequence. The data frame df has two columns, product underscore name and sales, where each row represents a product and its sales value. To calculate the cumulative sales total, we first define a window specification using window.order by sales. This specification orders the rows by the sales column in ascending order, setting up a sequence where PySpark can compute the running total of sales as it progresses through the ordered data. We then apply the sum sales dot over window underscore spec function to create a new column, cumulative underscore sales, which calculates the cumulative sum within the ordered window. For each row, this column shows the sum of sales from the start of the sequence up to the current row, effectively creating a running total of sales. Calling show displays each product sales along with the cumulative sales up to that point in the ordered sequence. This cumulative calculation is useful for analyzing how sales accumulate as you move through the dataset, providing insights into how individual sales contribute to the overall total when viewed in a specific order. This approach is particularly valuable in trend analysis, financial reporting, or any context where understanding accumulations within a sequence is beneficial. 2. Calculating cumulative sum within a partition. In this example, we create a data frame with product names, categories, and sales values, and use PySpark sum function with a window specification to calculate the cumulative sum of sales within each category. This approach allows us to see the running total of sales for each category independently. The data frame df underscore depth contains three columns: product underscore name, category, and sales, where each row represents a product, its category, and its sales amount. To calculate cumulative sales separately within each category, we define a window specification using window.partition_by_category.order_by_sales. The partition by category divides the data into independent groups by category, such as electronics and clothing. Within each category partition, order by sales arranges the rows in ascending order of sales. We then use sum sales dot over window underscore spec to create a new column, cumulative underscore sales, which calculates the running total of sales within each category. For each product, this column shows the cumulative sales up to that point within its specific category, giving a progressive sum as it moves through the order data in each partition. Calling show displays each product's sales alongside the cumulative sales for its category. This cumulative sum provides insights into how sales accumulate within each category independently, making it useful for comparing trends, monitoring category performance, or tracking progress within individual groups in the dataset. This technique is particularly valuable for data analysis tasks where grouped accumulations offer more granular insights than a simple overall total. 3. Using cumulative sum for time series data. In this example, we create a data frame that records daily sales over time and use PySpark sum function with the window specification to calculate a cumulative sum of sales in a time ordered sequence. This cumulative total helps us track how sales accumulate day by day, offering insights into sales trends over a period. The data frame df underscore time contains two columns, date and sales, where each row represents the sales amount on a specific date. To calculate cumulative sales as time progresses, we define a window specification using window.orderByDate. This specification orders the data by the date column in ascending order, creating a sequential timeline that reflects the natural progression of days. Using this window, we create a new column called cumulative underscore sales by applying sum sales dot over window underscore spec. This column calculates the cumulative sum of sales from the beginning of the dataset up to each specific date, resulting in a running total that updates with each additional day. When we call show, the data frame displays each date's sales alongside the cumulative sales total up to that date. This cumulative approach is particularly useful in time series analysis as it shows how sales build up over time, providing a clear view of trends, growth, or any seasonal patterns. This type of running total is beneficial for tracking performance over time, assessing sales progress, and forecasting future trends based on past sales behavior. 4. Calculating cumulative sum with custom range sliding window. In this example, we calculate a sliding cumulative sum of sales over time using a specified window of the last two rows in the dataset. This sliding window approach allows us to observe the cumulative total for the current row and the previous two rows, offering a localized view of trends or changes over smaller intervals. The data frame df underscore time contains two columns, date and sales, representing daily sales values. To apply a sliding cumulative calculation, we define a window specification that orders the rows by sales and uses the rows between two window.currentRow method. This setup specifies that the cumulative sum should include the current row and the two preceding rows in the dataset, creating a rolling or sliding window of 3 rows for each cumulative calculation. Using this window, we add a new column called sliding underscore cumulative underscore sales by applying sum sales dot over window underscore spec. This column shows the cumulative sales sum for each day based on the sales of the current day and the preceding 2 days. If there aren't enough preceding rows, e.g., for the first row or the second row, the sum will include only the available rows, gradually building up as more data is available in the sliding window. When we call show, the data frame displays each date sales and the sliding cumulative sales total based on the last 3 rows. This approach is useful for short-term trend analysis and localized insights within time series data, as it highlights recent changes or patterns over a defined interval, such as day over day changes in sales. 5. Handling partitions and default values. In this example, we create a data frame with product names, categories, and sales, and use PySpark sum function to calculate a cumulative sum of sales within each product category. Here we apply a window specification that starts from the beginning of each category and includes all preceding rows up to the current row, making it ideal for cumulative calculations across categories. The data frame df underscore depth has 3 columns: product underscore name, category, and sales, with each row representing a product's details and sales within a specific category like electronics or clothing. To calculate cumulative sales within each category, we define a window specification using window.partitionByCategory.orderBySales.rows between window.unbounded preceding window.currentRow. The partition by category function separates data by category, ensuring that cumulative totals are calculated independently within each category. Order by sales orders the data by sales within each partition, so cumulative totals build up progressively by sales amount. The rows between window.unbounded preceding window.currentRow range specifies that the cumulative sum should include all rows from the start of the partition up to the current row. This setup is especially useful for ensuring that cumulative totals begin from the first row in each category and continue to accumulate as new rows are added. With sumSales.over window underscore spec, we create a new column, cumulative underscore sales, that displays the cumulative sum of sales for each product within its category based on the specified order. When we call show, the data frame displays each product sales and cumulative sales total up to that row, helping to visualize the running total for each category independently. This approach is valuable for tracking cumulative progress within each group, such as observing category specific sales trends or monitoring performance over time in segmented data. And that's a wrap on using the sum function in PySpark SQL to calculate cumulative sums. We hope this tutorial clarified how to set up window specifications and track cumulative totals within your datasets. If you found this video helpful, please give it a thumbs up, subscribe to stay updated with our latest PySpark content, and don't forget to hit the notification bell. Thanks for watching, and we'll see you in the next video.